Hello, my name is Karen, and I'm going to give you a quick guide to our oxygen MicroOptodes. This guide will focus on the most important measuring characteristics of oxygen optodes. If you would like in-depth information and details about Unisense oxygen optodes, please see the lecture about Unisense optodes. This is a couple of photos of Unisense oxygen optodes. We make them with different cables and connectors so they can be applied both in the lab and in the field. The tip of a MicroOptodes consists of a light-transmitting glass fiber which is covered with a dye which fluoresces when illuminated. The dye is embedded in an oxygen-penetrable polymer matrix which sticks to the glass fiber with help from Unisense's proprietary method for glass surface activation. The dye is pulse illuminated by an LED through the light transmitting fiber, and the fluorescent dye at the tip back emits the light with a longer wavelength, which is then detected by a photodiode in the meter. Oxygen decreases the fluorescence and shortens the fluorescing period after illumination by the so-called quenching effect. The oxygen-dependent fluorescent lifetime can thus be used to estimate the oxygen concentration at the optode tip. By illuminating the dye with modulated light, the lifetime can mathematically be expressed as a phase shift between the illuminated and received light. The less oxygen, the larger delta phi. The phase shift is a stable value over time, and thus the optodes have very minimal drift. Detailed specifications are shown on our website. I will, however, elaborate on a few of the most important optode specifications. The model name indicates the tip size of the electrode. Thus, an optode 50 have a 50 diameter tip. We produce them in 3 different sizes, with the tip sizes of 50, 430, and 3000 micrometer. The latter is a low-cost, unbreakable optode for applications where small tip is unnecessary. See our tip selection guide to get information about which tip size to choose for your application. This guide will also help you in choosing between plug-type oxygen sensors and the optodes for your application. The detection limit is about 0.3 micromolar for the larger versions, whereas the up to 50 has a detection limit of 0.5 micromolar. For measurements of oxygen in the low nanomolar range, we recommend our amperometric stock sensor. An oxygen MicroOptode responds fast to changes in oxygen concentration. The up to 430 can be made in a fast responding versions with response times down to 0.3 seconds. The up to 3000 have a longer response time due to the longer equilibration time between the dye matrix and sample. We can modify and adapt our optodes, making them useful for a broad range of applications. For the micro-respiration systems, the optodes comes in this special guide, which allows for easy insertion into the small micro-respiration chambers. The optode body can be made in steel with threads, so it can be screwed into pipe systems or incubators. For use in closed flow systems, we can build the optodes into different gas-tight flow cells, ranging from these transparent glass flow cells to pressure-tolerant swage-like steel flow cells and peak flow cells. In general, if you have any special requests regarding adaptations, please do not hesitate to contact us. Thank you for watching this Unisense microsensor lecture. I hope you enjoyed it. If you have any questions, you are more than welcome to contact us at sales@unisense.com.